Hello everyone, welcome back to the session. I hope I'm clearly audible to all of you. All right, perfect. In the session yesterday, we spoke about how the IP addresses can be translated into binaries and tried looking at what is the distribution of network and host bits by default for class A, class B, and class C. And then we also tried figuring out how two IPs can be analyzed and can be understood if they are part of same network or not. Today, the complete session is going to be dedicated to subnetting. So we'll try out a lot of examples related to subnetting. We'll try questions related to class A, class B, and class C subnetting. So let's begin. Let's try understanding how subnetting works. We have discussed that class A, class B, and class C are something which are available for public use. And if I talk about the ranges of these classes, class A is going to be from 0 to 127, class B is 128 to 191, and class C is from 192 to 223, right? Every class has a distribution of network and host bits. In the class A, the network bits are 8 and the host bits are 24. In class B, the network bits are 16 and the host bits are 16. In class C, network bits are 24 and host bits are 8. We also discussed the formula about how we can figure out how many addresses a particular network offers belonging to each of these classes. This can be calculated by 2 raised to the power host bits, right? So 2 raised to the power 24 gives me 16 millions of addresses. And 2 raised to the power 16 gives me 35,000, sorry, 65,536. And 2 raised to the power 8 gives me 256 addresses. Assume that I have an organization. This is my building, and there are different floors on this building. On the ground floor, we have the sales team. On this first floor, we have the tech team. Here we have the finance team, and we have the marketing team. Let's assume that in sales team, there are 50 members. In tech team, there are 20 members. In finance team, again, I have, let's say, 50 members, and marketing team also contains 50 members. I want to make sure that all these different teams do not communicate to each other. So if I don't want to communicate them, I don't want marketing team devices to have a communication with finance team devices, tech team devices, and sales team devices. So what can I do? I can put them in different networks, correct? I can use different class C networks to make sure that they do not interact with each other, or to make sure that they are part of different network, right? So assume I got 210 1.0/24 for my marketing team, 210 2.0/24 for my finance team, similarly 3.0 for my tech team, and 4.0 for my sales team. If I put them in different networks, they'll by default not be able to communicate with each other. Do you all agree? Yeah. So this fulfills my requirement, but also does a lot of IP wastage. How? Marketing team requires only 50 addresses. And how many addresses does this IP network gives to me? Let me know in the chat box. It offers me in total 256 addresses, right? It's a class C network, has 24 bits in the network part. So 8 bits in the host part and 2 raised to the power 8 gives me 256 addresses. Out of 256, I am just using somewhere around 50 addresses. So there is a clear wastage of approximately 200 IPs, correct? Similarly, for the finance team also, there is a wastage of somewhere around 200 IPs. For my tech team, I have a wastage of 230 addresses. And for the last sales team also, a wastage of 200 addresses. That's wasting a lot of public IP addresses. And I pay money for that. I don't want to waste them. I want to utilize it as much as I can. And also because they are limited, they are available in a limited number. We should not be overutilizing it or wasting it for unnecessary use. So how can we manage this? What we can do is, instead of taking 4 networks from INA, I can just take one network, 210 1.0/24, and I'll break it down into 4 parts like this. One part of it I'll give to the marketing team, one part to the finance, one to the tech, and one to the sales. This is the process of subnetting, or we can say managing networks in a better possible manner by ensuring that we fulfill the requirement, but also do not waste IP addresses. But the question is that how will we identify how I can break it down into smaller parts so that one part can be given to the marketing team, other can be given to the finance, tech, and sales team, right? That's the main question. What is the procedure of calculating that? Let's see. I'll consider the same requirement. Assume that we are provided with a class C network, 210 1.0/24. Okay. Now it's a /24 network. So that means by default, the distribution of network and host bits is 24 in the network part, 8 in the host part, correct? I have a requirement of only 50 addresses. But how many addresses in total can I receive from this network? Two raised to the power number of host bits, which is 2 raised to the power 8, 256, correct? Out of 256, I require just 50 addresses. So I want to redistribute the network and host bits in a manner so that I can create small parts of my big network and I can use them as and when required. Okay, 8 bits give me 256 addresses, correct? I need to figure out how many bits would be required for 50 addresses. 8 bits gives me 256 addresses. I need to figure out how many bits would be enough for 50 addresses. All right, I'll share my screen again, guys, if some of you are facing issues with viewing the screen. I am sharing it again now. I hope it is visible now. Okay, let's get back to the discussion. We need to figure out how many bits of host would be enough for 50 addresses. So how do we figure that out? By calculating 2 raised to the power 0. This gives me 1. What does that mean? That means if I have 0 bits in the host part, I'll have only one IP. Then I'll increment the value. I'll try figuring out what is the value of 2 raised to the power 1. That gives me 2 addresses. So if I have one host bits, I'll get 2 IP addresses. Similarly, 2 raised to the power 2 gives me 4. 2 raised to the power 3 gives me 8. 2 raised to the power 5 gives me 16. 2 raised to the power, okay, I made a mistake there. It should be 2 raised to the power 4. So 2 raised to the power 4 gives me 16, 2 raised to the power 5 gives me 32, and 2 raised to the power 6 gives me 64. Now we have to see what number of host bits are fulfilling my requirements. So I need 50 IP addresses. Can I say that 2 raised to the power 6 can fulfill my requirement and can also minimize the wastage? Earlier it was wasting somewhere around 200 IPs. Now also there will be wastage, but only of 12 to 14 IP addresses, correct? So that means out of 8 bits, out of the total 8 bits, how much do I actually require for my requirement? I just require 6 bits, correct? So I'll subtract 6, 2 bits are extra. I'll give it to the network part. New distribution for network and host bits is going to be 26 and 6. Make sense? Once you have got this value, you can consider your question almost solved. Now you just need to calculate a couple of things and then you are good to go. The very first thing that you can calculate is number of addresses that your network will contain. So that's 2 raised to the power 6, right? As per the new distribution, I have how many host bits? 6. So 2 raised to the power 6, it gives me 64. Okay. After that, the next thing that I need to calculate is the subnet mask. Subnet mask I need to find out. So I have how many network bits? 26, and how many host bits? 6. So 26 network bits means 26 times 1. So 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24 dot 25, 26, 0, 0, 0, 0, 0, 0. This is the binary form. I need to convert it into dotted decimal. To get it into dotted decimal, I'll need my master formula. 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5, 6, and 7. This will be 1, this will be 2, this will be 4, 8, 16, 32, 64, 128. So first octet contains all 1. What is going to be the outcome for that, guys? If it is all 1, 255. Perfect. Similarly, for this octet also, it's going to be 255. For this one also, it's going to be 255. I need to know what will be the outcome for this one. So let's put it in the master formula and try to figure it out. It will be 1, 1, 0, 0, 0, 0, 0, 0. So I need to add 128 and 64. That gives me 192. So the last octet will have the value 192. And this is my new subnet mask for a network which is going to just provide IP addresses to 64 devices. Make sense? Okay, now as we have broken down a bigger network into smaller part, I also need to find out that how many such parts can I have, which means I need to find out the number of networks or the number of sub networks that I'll get if I break it down. This can be calculated by 2 raised to the power borrowed bits. How many bits are being borrowed here? 2, right? So 2 raised to the power 2, that gives me 4. This means that if I break down a big network into a part of 64 addresses, then how many such parts will be there? 1, 2, 3, and 4. Okay. Let's know what will be the first part. The last thing to calculate is range of IP address. Can I say my IP will begin from the very first IP, which is 210.1.0? That's going to be my first IP, right? So 210.1.0. I need to calculate 64 addresses in my network. So 210.1.0 is the first IP. Now let me know, what do you think will be the last IP if there are 64 IPs in my network? Perfect. 210.1.63. Why 63? I'll make it simple for you. Let's assume that you are counting from 1.0. And now I have asked you to calculate 5 addresses. So 1.1 will be the second IP, 1.2 will be the third IP, 1.3 and 1.4. This is going to be your fifth IP. Keeping that logic in mind, 64th IP will be 1.63 because we are starting from 0. Make sense? Now in this range also, the very first IP is something which we cannot use as it is considered as network ID, which is used for representing the network. And the last IP is also something that we cannot use as it is your broadcast ID, which is used for sending traffic as a broadcast to all the devices participating under that network. So guys, what is your usable range? Your usable range is 210.1.1 to 210.1.62. Is that clear, guys? Okay, that's your first part. Now, what is the benefit of doing subnetting? We have got such 3 more parts, right? Like if this is my big network, I have broken it down into 4 parts. So my first part starts from 1.0 and ends at 1.63, right? So from 1.0 to 1.63 is my first part. Similarly, there are 3 more parts, 1.64 to 1.127, 1.128 to 1.191, 1.192 to 1.255. And these other 3 parts can also be used for any requirement which is less than 62. Why am I saying less than 62? Because the first IP and the last IP is not usable, right? So the usable IP addresses are 64 minus 2, 62. So if I again get a requirement of 62 addresses or anything less than that, I can use these other remaining parts of my network for those particular requirements. Make sense? But if I would have used the complete network for just 50 addresses, then I cannot use the same network anywhere else, right? If I want that network to be separated into smaller parts, I have to calculate subnetting. I have to do the whole procedure that I have discussed. Is that clear to everyone? I'll talk about the complete explanation again with another example. So let's know how this happened again. Okay, we have a question, why dot 63, not 64? So Pooja, as we are starting from 0, we will consider 0 also, right? If I ask you to count 5 addresses starting from 0, it will be 1.0, 1.1, 1.2, 1.3, 1.4. 1.4 is your fifth IP, correct? Similarly, if I talk about the 64th IP, it's not going to be 1.64. Rather, it's going to be 1.63. We'll talk about such scenarios later on. As of now, we are discussing the parts of equal length. So yeah, we'll talk about it later. Okay, let's look at another example. Let's say the network we are provided with is 210 2.0/24, and the requirement is, assume that 100 IP addresses. By default, the distribution is 24 bits and 8 bits. I need to find out how many bits would be enough for 100 IP addresses. Again, I'll start counting from 0. 2 raised to the power 0 is 1. 2 raised to the power 1 is 2. 2 raised to the power 2 is 4. 2 raised to the power 3 is 8. 4 is 16. 5 is 32. 6 is 64. And 7 is 128. So I need how many bits, guys, to cover this requirement? 7 bits, as it gives me 128 addresses. So I'll subtract 7. 1 bit is extra. I'll give it to the network part. The new distribution will be 25 bits in the network part and 1 bit in the host part. Sorry, not 1, but 7 bits in the host part, right? First thing is number of addresses. Number of addresses is going to be 2 raised to the power 7, which is 128. Second thing I need to calculate is subnet mask. Let me know quickly what will be the subnet mask for 25 bits. Perfect. It's going to be 255.255.255. This is going to be the subnet mask for the first 24 bits. And because we have one extra bit, so the last octet is going to look like this. 1 and 7 zeros. If I put that in my master formula, 1 and 7 zeros. So what's going to be the outcome of that? It's going to be 128, right? I can say my subnet mask is going to be 255.255.255.128. Third thing is calculating the number of networks. How many bits are borrowed this time? 1 bit. So 2 raised to the power 1, 2. That means there will be only two parts. Finally, the range, if I calculate the range, I'll have to begin from 210.2.0 and I have to count 128 addresses. So the last IP will be 210.1.127, right? Out of which I cannot use the first IP as it is my network ID. And I cannot use the last IP also as it is my broadcast ID. So the usable number of IPs are 128 minus 2, 126. Any questions or doubts in this? Okay, so we have a question about range again. Uh, Range basically will begin from the very first IP, right? Range is about understanding what IP addresses will I use if I have to assign IPs to the end devices or the endpoints. Okay. So we will obviously begin from the first IP, which is 210.2.0. Now I have to calculate 128 addresses, right? So I'll begin from 2.0. That's my first IP. 2.1, 210.2.1 is going to be my second IP. 2.2 is going to be my third IP. Similarly, Varun, you tell me what will be the 10th IP? 2.9. Now what will be 128th IP? 2.127. So that's my range of 128 addresses. Clear now? Perfect. Okay, now I'll give you one question to try. These notes are open for you. You can refer to them and try to solve this question. You are provided with a class C network as 195.1.1.0/24 and your requirement is 25 addresses. So calculate and tell me what subnet mask and range should be used for 25 addresses. Take your time, calculate this, and let me know. Oh, yeah, thanks, Anuj. Thanks for pointing that out. This is 210.2.127. Yeah, so calculate the subnet mask and range for this question 195.1.1.0/24 and let me know what will be the subnet mask and the range for the devices. Okay, I assume everyone must have calculated this by now. I can see multiple responses in the group chat. Perfect. So let's have a quick look on how this can be solved. So we are provided with a requirement of 25 addresses with the network as 195.1.1.0/24. The default distribution of network and host bits is 24 in the network, 8 in the host part. For 25 IP addresses, I will go for 2 raised to the power 0, 1, 2 raised to the power 1, 2, 2 square is 4, 2 raised to the power 3 is 8, 2 raised to the power 4 is 16, and 2 raised to the power 5, which gives me 32 addresses. So I'll subtract 5. 3 bits are extra. I'll give them to the network part. Network part will become 27 and host part will become 5, right? The number of addresses will be 2 raised to the power 5, 32. Subnet mask for 27 bits will be 255.255.255.224. Number of networks, 2 raised to the power borrowed bits. We have borrowed 3 bits, so 8. And the first range will be 195.1.1.0 to 195.1.1.31. That's going to be my first range, in which 195.110 and 195.1.131 are not usable. They are the network ID and the broadcast ID. So the usable range is from 1.1 to 1.30. Okay, I'll explain again. My requirement was 25 addresses. First, I need to figure out how many host bits are enough for 25 addresses. So I started from 2 raised to the power 0 and I figured out that 2 raised to the power 5 covers my requirement with a minimum wastage, right? So by default, the distribution of network bits and host bits were 24 and 8. Out of 8, how much do I require? I just require 5. So I subtracted 5, 3 bits were extra. I gave it to the network part. New distribution became 27 and 5. The number of addresses can be calculated by 2 raised to the power host bits. So in new redistribution, the number of host bits are 5. So 2 raised to the power 5 is 32. 32 addresses will be there. Subnet mask can be calculated by looking at the network bits. Network bits are represented with 1. So 27 times 1 means 1, 2, 3, 4, 5, 6, 7, 8, dot 9, 10, 11, 12, 13, 14, 15, 16, dot 17, 18, 19, 20, 21, 22, 23, 24, dot 25, 26, 27, 0, 0, 0, 0. Clear? So this will be 255. Second octet will be also 255. Third octet will be also 255. The final octet, if you put the value in master formula, you will get the outcome as 224. That's what we have used for the last octet. Okay. Then Number of networks tells you that how many parts can be created. That's going to be 2 raised to the power borrowed bits, which is 3. 2 raised to the power 3 gives me 8 as the outcome. 8 means that there can be 8 subnets if I break down the bigger network into parts of 32 addresses. Okay. Then finally, I calculated my range. I started counting from the first IP 195.110 and calculated the 32nd IP, which will be 195.1.131. Questions? Okay, I'll give you one more to try. You are provided with 210.10.0/24, and the requirement is 32 addresses. Try to calculate this, take your time, and then we will speak about the solution. The notes were already shared in the group earlier. You can check the pinned messages, Mohammed. You'll find the notes there. Yes, Saurabh, the requirement is of 32 addresses, so calculate accordingly. Okay, so if you have got a requirement of 32 addresses, you have to keep in mind that two IPs will not be used, the network ID and broadcast ID. Keeping that in mind, calculate what do you think would be the correct subnet mask and range. And then I'll be speaking about the solution here on my screen. Okay, I'll make sure that you enjoy the class B and class A subnetting also, Ashraf. Don't worry about that. We'll get there after the solution of this one. This time we are provided with a network 210.10.0 with a requirement of 32 addresses. For 32 addresses, if I look at the bits, 2 raised to the power 5 can give me 32 addresses. But can I continue with that? No, right? Why? Because first IP and last IP is something that we cannot use. So we'll have to go for 2 raised to the power 6, which offers me 64 addresses, as my original requirement is of 32 IPs. So the default distribution is 24 bits and 8 bits. Out of 8, I require 6. 2 bits are extra. I'll give it to the network part. New distribution is going to be 26 and 6. First thing is calculating the number of addresses. 2 raised to the power 6, 64. Second is calculating the subnet mask. Subnet mask for 26 bits will be 255.255.255.192, right? Third is calculating number of networks, which will be 2 raised to the power 2, 4. And finally, the range, which will begin from 210, 10.0 and will end at 210, 10.63. Clear, guys? Okay, we have a question about subnet mask not able to calculate. Let's understand how we can do it. We have got 26 bits in the network part and 6 bits in the host part. So we discussed earlier that network bits are represented with 1 and host bits are represented with 0. There are 26 bits in the network part. That means 1, 2, 3, 4, 5, 6, 7, 8, dot 9, 10, 11, 12, 13, 14, 15, 16, dot 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 0, 0, 0, 0, 0. Now, for all 1 in any octet, the outcome is going to be 255. Do you agree, Abhi? Here also it will be 255 and here also it will be 255. Do you agree with this, Abhi? Yes, awesome. Last octet is double 1 and 6 times zeros. I'll simply put it in my master formula: 2 raised to the power 0, 2 raised to the power 1, 3, 4, 5, 6, 7, 128, 64, 32, 16, 8, 4, 2, 1. So I'll put these values 1, 1, 0, 0, 0, 0, 0, 0, 0. What will be the outcome, guys? Pooja, Abhi, let me know. What do you think will be the outcome of this? 192, right? So for the last octet, the value is going to be 192. Now you know how your subnet mask is becoming 255, 255, 255, 192. Is it clear now? Perfect. Okay, now if I ask you, are you guys ready to calculate any subnetting question related to Class C networks? Do you find yourself prepared for Class C? Awesome, that's great. Deepak, to calculate the block size, you just need to use the host bits on the power of 2. You'll get the block size. It's 64 in our case. Okay, we have another question about the other parts. So let's also try to calculate the remaining three parts of this particular network. This is my first part here, starting from 210.10.0 to 210.10.63. That's my first part, right? The second part of this network will be 200.10.10.64. Yeah, 210.10.64 to 200.10.10.127. That's going to be my second part. Third part will be 210.10.128 to 210.10.191. That's the next 64 IP addresses. And finally, the last part will be 210.10.192 to 210.10.255. That's the last part. We have a question, another question. What is the use of public addresses when we can use private and use NAT? You can definitely use NAT configurations, but Michael, there can be certain situations or certain scenarios where you might want to use public IPs for multiple routers, right? So in those situations, you can go for implementing subnetting. All right, we will move to the class B questions then. But before we jump onto that, number of network, is there any formula? Yes, there is this formula 2 raised to the power borrowed bits, like I explained earlier. 2 raised to the power borrowed bits. So in this case, how many bits are being borrowed by the network part? 2 bits. So 2 raised to the power 2, 4 networks. And these are the 4 networks. 1, 2, 3, 4. Okay, let me know quickly. Are you guys enjoying the course so far? Do you like how we are studying about CCNA fundamentals and talking about the basics and the concepts? That's amazing. Great. So I'll give you a break of 10 minutes and would also request you to uh, share your feedback on this link, which I have pasted. Whatever has been your experience so far, on the basis of that, you can share your feedback on the link. And if you wish to do it later on, maybe after a few more classes, then that is also fine. Totally up to you. If you want to do it right now, then please do it. Otherwise, we can also collect the feedbacks later on after a few more sessions, maybe. Yeah. And then we have a break of 10 minutes now. So I'll see you guys in 10 minutes. Thank you so much. I am hoping that you guys are enjoying the sessions. So see you in 10 minutes. Then we will learn how Class B and Class A subnetting works. Okay, everyone must be back from the break by now. It's time to learn how Class B subnetting works. Are you all excited to learn the Class B subnetting? Okay, perfect. So guys, I'll tell you very honestly, it's very simple, very easy, and just need a little bit of calculations. That's it. Rest everything stays the same. Just like we have learned it in Class C, we'll apply the same learnings in Class B. Now let's say I am provided with a network 150.10.0.0/24. Not 24, now it's Class B, so it's going to be /16. And the requirement is of 500 addresses. Okay. The default distribution of network and host bits is 16 and 16. Correct? I need to know what number of bits will have 500 addresses in it. 2 raised to the power 8 we have discussed, it's equals to 256. Yes. So 2 raised to the power 9 is going to be double of that, making 512 addresses. 512 definitely fulfills my requirement and does minimum wastage, right? So out of 16 bits, how much do I require? 9 bits. 7 bits are extra, I'll give it to the network part. New distribution of network and host bits will be 23 in the network part, 9 in the host part. Clear? Number of addresses we discussed, 2 raised to the power host bits, 512, right? Second thing we calculate is subnet mask. For subnet mask, the network bits are 23. Okay. So 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24 dot 25, 26, 27, 28, 29, 30, 31, 32. What's going to be the value for this? 255, right? For the second octet also, it's going to be 255. For the last one, it will be 0. I need to figure out for this one. So for this one, I'll use the master formula again. 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 4, 5, 6, 7, 1, 2, 4, 8, 16, 32, 64, 128. And 1, 2, 3, 4, 5, 6, 7. 7 times 1, and the last bit's gonna be 0. The maximum we can get, or the total of this all bits, is 255. Now we are not considering 1. So what will be the outcome? 254, right? We are not considering the last one. So the outcome of this is going to be 254, correct? So that's going to be my subnet mask. Okay. The third thing we calculate is number of networks. How many bits are borrowed this time? 7 bits. So 2 raised to the power 7. That means 128 networks can be created out of a class B network if we break it down into smaller parts of 512 IP. Here comes the real challenge, which is calculating the range. Range will begin from 150.10.0.0. And I have to calculate it for 512 addresses. So what do you think? What's going to be the last IP? As per the logic that we have applied, it will be 150.10.0.509, right? But we also know we cannot have anything greater than 255 in any given octet. That's going to be incorrect, very obviously. Okay. So let's see how we can find out the range. To calculate the range in scenarios where your number is greater than 256, what you have to do is you have to divide your number by 256. When you do this division, you will get 2, right? This means that I will need 256 addresses 2 times to complete my requirement. Yes or no? So the first 256 addresses will be 150.10.0.0 to 150.10.0.255. These are going to be my first 256 addresses. Then the next one will be 150.10.1.0 to 150.10.1.255. Correct? If I combine them, I will get my original requirement fulfilled of 512 addresses. I mean, I'll get the total 512 addresses. So a combined range of this would be 150.10.0.0 to 150.10.1.255. So this is my actual range, which I have got after the calculation. And now we know basically how to do it. Easy, right? That's how the class B subnetting is done. I'll give you one more example. One 150.11.0.0/16, and the requirement this time is 2000 addresses. I would say the only difficult part or a little complicated part is finding out the number of bits. Once you have got that, you are good to go, right? So for 2000 addresses, I have to figure out how many number of bits would be required. The default distribution is 16 and 16. 2 raised to the power 9 we just have discussed is 512. 2 raised to the power 10 will be double of 512, 1024. 2 raised to the power 11 is going to be double of 1024, which will be 2048. Does that fulfills my requirement of 2000 addresses? Yes. So I got the answer. Out of 16, I require 11 bits. How many bits extra? 5 bits. Give it to the network part. New distribution is 21 and 11. First thing, number of addresses. 2 raised to the power 11 is 2048. Second thing is number of networks. 2 raised to the power borrowed bits, 5. That's 32. Third is subnet mask. Subnet mask for 21 bits. So 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 0, 0, 0, and then all zeros. This will be 255 dot, this will be again 255. Let me know quickly, what do you think will be the value for this one? Where we have the first 5 bits as 1. 248. Then 0. Then comes the final part, which is calculating range. Calculating range requires me to divide this by 256. When you will calculate this, you'll get it as 8. Okay, if it is 8, my range will begin from 150.11.0.0. Then we'll basically require 8 times 256 addresses. So first would be 0.0 to 0.255. Then 1.0 to 1.255. Similarly, 2.0 to 2.255, 3.0 to 3.255. And if you count it for 8 times, you will find out the last one is going to be 150.11.7.0 to 7.255. That's my final range for 2000 IP addresses. Any questions or doubts in this? Okay, the question is that why do we divide by 256? So Ananya, the thing here is that the maximum you can have in your one octet is 256, or being specific 0 to 255, right? You cannot go beyond that. So it's pretty obvious that my range cannot be 150.11.0.0 to 150.11.0.2000 or something, right? I can only have a maximum of 255 in my octet. So I need to know what number of change do I require in my third octet to fulfill my requirement. Make sense? So we divide it, we got the value 8. That means 8 times 256 addresses makes it 2048 addresses. So now I can get the calculations done directly here. I can simply write down 150.11.0.0 to 150.11.7.255 because that combines 8 ranges 0.0 to 0.255, 1.0 to 1.255, 2.0 to 2.255, 3.0 to 3.255, 4.0 to 4.255, 5.0 to 5.255, 6.0 to 6.255, 7.0 to 7.255. If you count them, these are 8 in number. So they combinedly together bring 2048 addresses. Make sense? Sure, definitely. We'll have one more example. Don't worry about that. Okay, how to do it with speed? There are multiple tricks that you guys can explore by yourself on internet. I don't support that. My job is to make you understand the concept and teach you how to do it through the right way. But then, yeah, definitely there are tricks that can make it make the calculations very simple and easy. But right now, like I said, our purpose or agenda is to get the concept. So first we will work on understanding the concepts. Then later on, maybe if we'll find some time, I'll introduce you how you can do it through some tricks that can help you in doing it very quickly. Okay. And definitely, like you mentioned, Anuj, a good practice can make you good at it and you will achieve a better speed of calculation. Let's look at one more example now. One 160.10.0.0/16 with a requirement of 5,000 addresses. Okay. So I just calculated the number of bits required for 2,000 addresses was 2 raised to the power 11, which gives me 2048. So 2 raised to the power 12 will be 4096, which is double of 2048, and 2 raised to the power 13 will be 298192, which is double of 4096. Yeah. So 8192 can fulfill my requirement of 5,000 addresses. So network host 16, 16. How much do I require? I require 13. 3 bits are extra. I'll give it to the network part. Network bits 19, host bits 13. Number of addresses 8192. When you will divide this by 256, you will get 32. You can use calculator as well. I'll just cross check 256 multiplied by 32. Yeah, 8192. So yes, 256 is going to bring us the value as 32. Second thing, number of networks, 2 raised to the power 3. That's going to give me 8. Third thing, subnet mask. For 19 bits, it will be 255.255.224.0. I have taught you how to calculate it. So if you have got a question, you can put it in the master formula and you will know how 224 is getting as the output, right? Lastly, the range, as we have got 32 after the division, I can assume that my range will be 160.10.0.0 to 160.31.255.255. Sorry, 160.10.31.255. Clear, guys? Any questions or doubts again? Okay, so I'll give you some questions to try by yourself now, and then we'll speak about their solution. 150.10.0.0/16 with a requirement of 1000 IP addresses, then 150.20.0.0/16 with a requirement of 4000 IP addresses, and 172.19.0.0/16 with a requirement of 10,000 IP addresses. Go ahead, try to calculate this, and we'll speak about the solutions afterwards. Okay, shall we look at the solutions now? All right, let's try from the first one. 150.10.0.0/16 with a requirement of 1000 IP addresses. For 1000 IP addresses, I can go for 2 raised to the power 10, which gives me 1024 IPs. Yeah. Network and host distribution by default is 16 and 16. I need 10 bits, so 6 bits are extra. I'll give it to the network part. New distribution will become 22 and 10. Number of addresses 1024, right? Number of networks 2 raised to the power 6, 64. Subnet mask for 22 bits will be 255.255.252.0. To calculate range, I can divide this by 256. I get 4. So my range is going to be 150.10.0.0 to 150.10.3.255. Is that clear to everyone? Let me know if there is any doubts or queries. Number of networks means that how many networks will we get if I break down the bigger network into smaller parts having 1024 addresses. So if each part has 1024 addresses, how many parts will I get out of a class B network? So I will get 64 such parts. That means 1024 addresses can be used 64 times if I am given with a class B/16 network. Make sense? We can calculate that by 2 raised to the power borrowed bits. How many bits were borrowed? 6 bits. So I said 2 raised to the power 6, 64. Why is it 255 rather than 256? Akshat, we have discussed this previously with the master formula that the maximum that I can get if I keep all my bits on, if we keep all the bits on, what do we get as the maximum? Yes, Akash. If we keep all the bits on, these are the 8 bits of my octet, right? If I keep all of them as on, I get 255. That's the maximum I can get. And it begins from 0. So 0 to 255, if you think of, is actually 256 addresses only. But yeah, the last IP is going to end at 255. Okay, let's look at the second solution now. 150.20.0.0 4000 addresses. 2 raised to the power 10 is 1024. 2 raised to the power 11 is 2048. 2 raised to the power 12 is 4096. 4096 can be used for my requirement of 4000 addresses, right? The default distribution of network and host bits is 16 and 16. Out of 16, I require 12. 4 bits are extra, I'll give it to the network part. The new distribution of network and host bits will be 20 and 12. As per this, we'll calculate number of addresses. 2 raised to the power 12, 4096. Then I'll calculate number of networks. 2 raised to the power 4, that's 16. Then I'll calculate subnet mask. For 20 bits, subnet mask is going to be 255.240.0, right? And to calculate range, I'll divide this by 256. I'll get 16. So my range will become 150.20.0.0 to 150.20.15.255. Jyoti, I can see you have calculated it correctly. There is a minor mistake in the range calculation. Please do check that. Let me know if there is any questions or doubts in this one. How we got 240? Ravi, try to calculate it by yourself. There are how many bits? 20 bits in the network part. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 0, 0, 0, 0 dot 0, 0, 0, 0, 0, 0. If you try converting this into decimal, you will get 240 by putting it into the master formula. So when you divide 4096 by 256, you'll get 16, right? Okay. So we'll get 16 if we divide 4096 by 256. I need 256 addresses 16 times. That's why my range can't be up to 11.255. Yep. Okay, let's look at the last one now. Last one is 172.19.00 with a requirement of 10,000 addresses. So 2 raised to the power 13. Okay, we calculated it for 12, right? 2 raised to the power 12 was 4096. 2 raised to the power 13 will be 8192. But my requirement is of 10,000 addresses. So I'll move ahead. 2 raised to the power 14. That's going to be 48316. 16384. So the default distribution of bits is 16 and 16. Out of the 16 host bits, I require 14. 2 bits are extra, I'll give it to the network part.
My network part will now become 18. Host part will become 14. Number of addresses 16384. Number of networks 2 raised to the power borrowed bits, that is 4. Subnet mask for 18 bits will be 255.255.192.0. Then the range. For range, I'll divide this by 256, and when I'll do so, I'll get 64. So my range will begin from 172.19.0.0 to 172.19.63.255. That's going to be my range for the third network. Clear, guys? Okay. Let's look at a class A example, and then we will be good for the day. So class A is when you have requirements greater than 65,536. Let's assume that we are provided with a class A network 8.0.0.0/8. Okay. And the requirement is of 100,000 addresses or 1 lakh addresses. Yeah. First of all, I need to find out what will be the number of bits required for 100,000 IP addresses. So 2 raised to the power 16 is 65,536, correct? 2 raised to the power 17 is going to be 2, 7, 0, 11, 13, 131072, which will fulfill my requirement of 1 lakh or 100,000 addresses. The default distribution is 8 and 24. Out of 24, I require 17. So 7 bits are extra. I'll give it to the network part. The new distribution will become 15 and 17. Number of addresses is equals to 131072. Number of networks is equals to 2 raised to the power 7, that is 128. 7 is the borrowed bits, right? Subnet mask. Subnet mask for 15 bits will be 255.254.0.0. You can calculate that by putting it into the master formula. Last part is calculating range. So we discussed that if the number is greater than 256, we'll divide it by 256. When you do this division, you'll get the outcome as, I'll check it. We get the outcome as 512. Now 512 is also greater than 256, right? I cannot define that in my range. So what I'll do is I'll again divide it by 256 so that I can know what change needs to be done. First, when we divide by 256, we learn how many times we want to modify this bit. Then when we divide it again, we get to know how many times we want the change to happen here. So when I divide it again, I get the outcome as 2. So I can understand that my range will be 8.0.0.0 to 8.1.255.255. This is my complete range for 131072 addresses. And if for your understanding, if I break it down, it is 8.0.0.0 to 8.0.0.255, right? Then 8.0.0. Not 8.0.1.0 to 8.0.1.255, so on until it reaches 8.0.255.0 to 8.0.255.255. After this, what will be the next IP? The next IP will be 8 dot. Now the change will happen in this bit. So we'll begin from 8.1.0.0 to 8.1.0.255, going on till we reach the last, which is 8.1.255.0 to 8.1.255.255. So if you guys can calculate or understand this, it is basically 255 addresses, 255 times for twice. 255 addresses, 255 times for twice, right? So if you calculate that, 2 multiplied by 255 multiplied by 255. So this is going to result into 65,536 multiplied by 2, which will be 131072. No, you will not get subnetting questions to completely calculate from the starting to the end in your exam. You will be just tested on how basically a subnet is evaluated. You will be provided with some details and you'll be asked questions based on that. That if the network is 192.168, 5.0 slash, let's say 27, then does this IP belongs to the range or not? Things like that will be prompted. But you don't get questions with that level of calculations in the exam. But yeah, I do have this question for you all. Is it all clear to you how the class A works? Basically, you divide it twice this time. And when you divide it twice, the change will happen in the second octet, not the third octet. Sure, definitely. Here are some questions for you guys to try. One 172.16.0.0/16 with a requirement of 5,000 addresses. 172.16 or let's say 17.0.0/16 with a requirement of 12,000 IP addresses. And from class A, you are provided with 1.0.0.0/8 network with a requirement of 500,000 IP addresses or 5 lakh IP addresses. You can try these questions and I'll share the results and the solutions in the chat in the group so that you guys can verify. And that was all for today. Thank you so much. There is one last important information for you all that tomorrow we have a webinar which is about subnetting. So I'll really appreciate if you guys can join that webinar as it will help you in revising the concepts. I'll remind you about this webinar tomorrow also. It's at 6 p.m. IST. So we are going to talk completely everything related to subnetting. And it's going to be a good, helpful session for you to revise these concepts. I'll ask my team to drop the link in the Telegram group so that you all can register for it. And yeah, that was all for today. Do practice the questions. Do try attempting these homework questions, and we shall connect tomorrow at the same time. And yeah, we'll continue further discussions on the CCNA fundamentals. Awesome. That's great. I'm glad you guys enjoyed the class. Take care. Bye bye. See you tomorrow at the same time. Do practice and keep learning.